Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So, the chat was kind of not really working just a second ago, so if someone wants to say something in chat, I guess I will. Hi? Yes, okay, it is working now. Sorry about that. For some reason, I was able to see it on my screen. Today has just been a host, like a whole slew of technical issues. So, Kodo, Hayes, Anderson, and anyone who might be lurking in chat, hey, thanks for being here. I realize you're not on screen yet, but yeah, I think everything's fixed now. Like, man, today's been rough. Just in terms of just technical issues, but that's okay. Hey, Trash Talk, how are you? Right, so the title for today is still Becoming a Fractal. That's because I've decided that in this year, I'm going to just have the stream titles be like one consistent title for the big projects that we're working towards. So again, we are working towards the Fractal Flameify package. That's what we're working on. We are going to continue to work on that for the next a few weeks, but the kind of subsection that we're working on today is specifically the convolution, and in particular the convolution chapter for the algorithm archive, which is not done, but sussed out enough that we can figure out what the images are that we want in the chapter, and that's kind of the goal for today's episode. We'll see how long it goes. I'm actually pretty excited, so we should get pretty far. That's Udar. Hey, how are you? And we're just going to knock it out, see where we get. Again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. I guess the only real side note I have is that I will be doing Writing Wednesday on Wednesday again. Trash Talk, since you're in chat right now, and you're the one that has been submitting most of the writing to the writing repository on the algorithm archive, which I may or may not, I mean, if you want to, we could read aloud on that day, but also we could do something else if you want. I was planning to do another Writing Wednesday instead of a weekend writing stream. So maybe every Wednesday we just have a 2-hour session. I was thinking from 6 to 8 p.m. Eastern, but that might be a bit late for people. So maybe we do it in the middle of the day. It's pretty dead, I know. No, well, it's not that it's dead, it's that I haven't really been pushing it, you know? And I think if we try to push it, we could do pretty well. I mean, look, my writing, I want to do stuff to improve my writing. Like, that's what I want to do. And in order to do that, I need some sort of incentive to do it, so I will certainly be doing Writing Wednesdays. The question is, at what time is best? Should we do it maybe at the start of stream or at the end of stream? I'm not really sure. So I think I am going to be trying to find like better stream times. So this week, Writing Wednesday will be from 6 to 8 p.m. Eastern time. However, in subsequent weeks, once I have like my kind of stream schedule sussed out, I'll try to do it earlier in the day. It just kind of depends. So sometime on Wednesday, we will focus on writing for a few hours before moving on to other stuff. Hey, Board Spaghetti, how are you? Simmy Limmy, I've not heard that one before. Don't know if I like that one or not. It's the Satchad. Stat Chad. Oh, wait. Okay, I don't remember. Someone called me a Chad for some reason. I don't remember why I was called Chad. However, I did have a conversation with my girlfriend's family, and her grandmother thought I looked attractive, so I have that going for me as far as the Chad, lingo is concerned. Pretty good, studied E&M all day. That sounds like a day. I don't know if that's a good day or a bad day. It kind of depends on who you are. I know personally, I did enjoy the E&M class that I took in university. It was my favorite, just period, because I could very easily simulate everything via finite difference time domain or something scheme. It was actually quite a lot of fun. So, enum class? Oh, enum. Oh, E and M, not enum. Slightly different. Right, so I don't really have any further updates, so I think I'm going to go ahead and CD into Projects Algorithm Archive. Projects Algorithm Archive, L is here, and just run npm run serve. Make sure I'm in the right branch. I should be. I was just there earlier. Right, so we'll give it a second to build, and then I'll just pop it up, and we'll talk about where we're at and what the plan is for today's stream. I shared something cool in off topic. Oh, actually, maybe I'm just pulling it up right now. Why not? Off topic. What is this? Oh, is this? That's super cool. Yeah, I'm a fan. Yeah, good job. Like, I know I might sound like, but a lot of times when I'm telling people, you did a great job, I sound very condescending. Don't mean that at all. Like, that is way better than something I could do. At this stage, I really need to get better at modeling. That's actually phenomenal, honestly. For 3 hours of work, like, good job. All right, let's go over here. I'm going to grab this, oh, no, not that. Let's grab this. Okay, I'm going to ask you guys a dumb question. A question that I feel like I already know the answer to, even before asking. And just be honest. Just be honest. When I ask this question, don't judge me for it. But how do you guys copy and paste? Like, what do you do with your keyboard and mouse to copy and paste something? That is my question. I know this is a dumb question. I'm going to explain it in just a second. Control C, Control V, right? That's what most people do. 3 hours for a 2-second animation. Look, we've spent hours on very similar things. Like 3 hours for a 2-second animation that looks that good is pretty good. Right. Control X if I'm moving lines in a script. Do right click, copy, and then shift insert. No, so with Linux, control and click 2 for selecting. Control plus click 2 for selecting. Control plus, interesting. Okay, so I'm learning that I must be one of the very few people that uses this particular method of copying. Yeah, I only do middle click. That's the only way I copy and paste. That's it. Like, I hate pressing Control C and Control V. It's just it's hard. Like, first of all, Control C is like a weird keybind for me. Yeah, I use trackpad for it all, right? Like, that's what I do. Okay, I'm not the only one then. I'm happy to hear that. But yeah, I generally like, middle click doesn't work on the fly. What do you mean it doesn't work on the fly? So I don't know. I mean, you're right. Recently there have been web applications, that don't allow the middle click. And it's kind of a pain. So I was just wondering, like, middle click requires moving mouse finger around and also moves the cursor when you middle click. Does it? No, you just highlight and then you press. Maybe. Trackpad, how? No button either. Yeah, so what I do is I literally just highlight, and without pressing Control V or Control C, I just paste it. Like, just with the middle click. This middle button will allow you to paste it in Linux, right? You enable the Firefox, use auto scroll. You need to enable auto scroll. It doesn't move cursor in a terminal, but text editor, etc. I see. Right, okay. So I guess maybe the reason I've gotten used to the workflow is because I only really type in terminals. Therefore, I don't really need... Yeah, but if you're going to Control C and Control V, you still have to highlight the text. Therefore, you're still moving the cursor. Anyway, I'm being a bit pedantic. I need to stop being so pedantic. I double tap my finger to drag a selected container. Huh. I prefer to use keyboard, so Control works better for me. Fair, I guess. How do you middle click with a pen though? It's so I don't know if you can tell in the. I can't really see what you can see, but there's 2 buttons on the side of the mouse, up and down. So one is for right clicking, the other is for middle clicking, and then if you press down, it does left clicking. Yes, I think that's correct. Maybe it's the other way around. One is right click, one is left click. I don't really know what's what. That's way easier then. Yeah, so honestly, this is phenomenally easy. Like, using a pen has like dramatically changed how I use my computer. Like, I genuinely love using this trackpad as a mouse. Or this this tablet as a mouse. It's my favorite mouse I've ever used by far. I have to use Control Shift C and V for copy paste in the terminal. Maybe Control Shift would work. The middle click is great for copy paste, but darn KDE messed up the clipboard. I disabled their clipboard, and copy paste now works as long as you don't close the window where you made the copy. Moving finger to auto scroll wheel is painful for the finger. So, like, you're talking about this motion? Honestly, this motion, the motion of clicking, I know I'm sounding like I don't know, I am sounding like either a really old man or a really whiny teenager, depending on your perspective. But clicking is so annoying, you know? Like, it's a mouse that only works with the trackpad. However, today, I did break down and I bought another mouse. Now, hear me out. I wasn't going to. I have this thing that's called Easy Stroke. So if I just run Easy Stroke, stroke here. I updated, now it doesn't work. Yay-S Easy Stroke. Try this again. Yeah, sure, why not? Let's go. None, yep. Just to show none. Perfect. All right, give it a second to load all the downloads instead, you know? And then we'll do it from there. So now if I run Easy Stroke. No, what? Crap. Well, I used to have this thing called Easy Stroke that I would use all the time, but now it doesn't work. But the point was that I could just like move my pen in particular fashions and would put certain keys into the so if I move it down, it'd do 1. If I move it here, it does 2, 3, 4, 5, 6. So I have certain swipes that correspond to certain keystrokes. So it used to be when I played video games or something like that. Yeah, it's gesture typing, right? So it used to be when I did video gaming or something like that, I would really just like have certain swipes that correspond to certain skills, and that's what I would do. And it worked pretty well. The problem was just recently, as of the past few weeks, for some reason, the 2 games that I play in this way, which are Guild Wars and Guild Wars 2, which I really haven't even played at all this year, I found out do not, or for whatever reason, do not work anymore with my tablet. I can't move the camera around as I wanted to. So I ended up deciding that I would, end up buying a mouse. So I've just today bought a mouse for the first time in like a year and a half or 2 years. It's been a long time since I had a mouse. So I bought a mouse just to play Guild Wars because one of my friends wanted to play it with me, and I'm like, well, okay, I don't like playing games alone, but maybe playing them with friends would be kind of fun. I'm not really sure. I use middle finger. Let me catch up, chat. I'm missing a lot of chat here. Middle click is great. Moving finger, scroll wheel. I keep my pinky on the control key. See, that's the thing. It's really hard for me to put my pinky on the control key. Like, I don't know how normal people do it, but like, I don't understand. Like, you'll be playing games or whatever, and they're like, oh, crouch with the control key. It's like, how do you press the control key while also pressing W, A, S, and D? In fact, how do you press the shift key while also pressing W, A, S, and D? I can't. It's just a hard button to press, Like, I can see, like, okay, so if one hand is on the mouse, and the other hand is on WASD, that left shift is really hard to hit. The left control is impossible to hit. So, like, I don't understand. I guess I don't understand keybinds is my problem. Let's see. That's why I prefer using keyboard. It's less clicking. Let's see. Scroll wheel. Yeah. So the mouse really helped with the clicking for me. That way I don't, or the pen really helped with the clicking, so I don't have to press my middle finger all the time. You play video games with gesture pen? Yeah, it was super fun. Like, it is actually super fun. I really enjoy it. I'd recommend it. Let's see. He does everything with the pen. Oh, wait, no, it's super hard. Like, I don't understand how you do it. Like, your hands are like this on the keyboard, right? So if your hands are like this and the shift key is over there, you have to like bend your shoulder in order to press the button. It's hard. I don't know how, again, maybe if the keyboard split, it'd be easier. But like, I mean, okay, let me just draw this out because I'm doing a bad job of explaining this. Also, I don't know why we started today with a ramble session, but that's okay. I don't mind. So here's a keyboard, right? So your hands are going to be like, here's your little, so okay. Let me just make sure I'm getting the angle right. My hand is coming in at this angle here, and my other hand is coming in at this angle here, right? So that means that my pinky, wait 1 second, 2, that's my middle finger, 3, 4, okay? I'm really bad at drawing, hear me out. So like, okay, the point is, my pinky, I did draw this a little bit wrong. On the keyboard right now, my pinky is this direction, right? So like that's naturally my pinky is this direction or this direction, right? So like in order to press the control key, which is over here, I've literally got to rotate my entire arm over a bit so that it's facing another direction so that I can hit the keyboard. Like it's super hard. Especially if you've been doing it since you were little. I have long hands, it's easy for me. At least I think Arch doesn't mess around with okay. At least I think Arch doesn't mess things out between upgrades. Fedora KDE 33 was a mess for me. A lot of things that shouldn't be there. A login screen wallpaper changes slightly. Still doesn't work. And there was this mess from NVIDIA drivers and kernel. Okay, maybe not KDE issue. Then I have this weird bug on YouTube. Only my second monitor. The videos from YouTube have translucent effects, and I can see from the desktop. Yeah, so, okay, for me, Twitch is being an issue, but that's the only real issue I have usually between updates. It's usually fine. It's very easy. I have long hands. It's easy for me, especially if you've been doing it since you were little. That's not what I was saying. I was just moaning about things. Do you have some kind of finger or joint stiffness condition? Not really. I mean, my finger hurts a bit if I click too much, but it's usually fine. Depends on your hand size. Maybe it's harder for short hands. If you update a program, but its dependencies or vice versa, stuff is just going to break. That's just how computers work. I have my hands on the home row and can effortlessly, there we go. I'm not saying that word effortlessly. Bend pinky down to control. Didn't realize this was a problem for some people. That's why I have full arch mirror locally so that I can still install. That's amazing. So I can still install new programs without having to do a full update every other day. I think the left hand is rotated more counterclockwise and towards the left edge of the keyboard. Fedora has packages, and they do allow upgrades between releases, so the dependency should be done by default. Okay, I'm going to do something dumb then here. Give me just a second. I'm going to do this, so I'm moving to the Ramble Laos mode, and you should, let me check, so it should just be me. I'm going to, how am I going to do this? I'm going to turn this down so it is facing my keyboard. I'm sorry, this is so, I know I'm being really dumb here. So there's my keyboard, right? So you guys should be able to see my keyboard. These are where my hands are, right? So here's the home row key. There are my hands on the home row key, right? Pressing control has to force me to bring my hand all the way over here, which is definitely not normal. Here's where they are normally, right? So my point is, sure, they're on the home row key. That's totally fine. I can move all around. That's okay. But like, and I can press this button. This button's kind of hard, but the control is like super hard. It's just impossible. Now, like, I just don't understand. Because, like, you see that in order to press this button comfortably, like, so here's the normal thing. You see that my hand here has to completely rotate all the way to get that key, I guess I could bend my pinky down, but that's hard. Like, you're asking me to press this key like that? That's super hard. That's really hard to do. Don't put fingers on home row for WASD gaming. Let's see. I'm reading chat right now because I'm actually kind of a bit I'm interested in this. Left hand is rotated more counterclockwise and towards the left edge of the keyboard. That's why I have a full arch mirror locally, so I can still install new programs without having to do a full. Fedora has packages, and they allow upgrades between releases. Fancy watch? Yeah, sorry, I've got stuff on my desk. What are you rambling about today? I wonder if anyone is more hardcore than Arch and uses Linux from scratch. My hand rests on the corner of my key, so that my pinky. Try bending your pinky. Don't put fingers on home row for WASD gaming. No, you bend the pinky. Are those gloves for warmth? It's something, well, it's for a number of different reasons. I bend the pinky slightly to press control. I don't have to move my hand to press it, only the finger. Yeah, you haven't played FPSs too much. Yeah, I just stretch, but that's the way to bend the pinky. I'm guessing you've never considered playing guitar. Let's see. You learn left control from FPS games. I rotate my hand to get something like W so that my pinky stays on the control key. Okay, so let's say I do move. Okay, so I think usually I'd put my middle finger on W. Like, I guess this is normally what I'd do. I'd put my middle finger on W, ASD. So if I was playing a game, right? I guess. And I can still hit this shift. But asking me to hit this control is, you're asking me to press the key. That's hard. I still don't understand it. It's a really hard thing to do. Because like, you're asking me to press this control with my pinky essentially bent like, essentially bent like, so if this is the keyboard, my pinky has to bend like this to press the key. Right? So it's like, it has to bend inward to press the key. Anyway, I don't know why I got on that ramble session. I'm so sorry about that. Let me go back to this screen and move my camera back up. 1 second. It's probably about right, I think. Is that right? Maybe I need to move it this way a bit? No, the other way a bit. That should be fine. It's fine for now. Okay, keep your hand in that position, and use it. No, I just can't. Like, my finger does not have enough pressure to press that button. It's hard. I think your hand has curled up too much. Try keeping the fingers WSD and move your hand down a little. So wait, okay. You're saying that. Okay, let me think about that then. So here's the keyboard. Naturally, my fingers are in this position when they're touching the keyboard. So you're saying you're saying the fingers should be in closer to this position. Like just extend the fingers back. Maybe. That's super uncomfortable. But maybe if I learned it that way, it'd be fine. I don't know why I got on this rant thing. This is, like, I don't know. Like, I don't think length is the problem. The problem is his pinky's too far up and he has to bend it down. The bending is the problem. Yeah, I mean, you might be right. Again, maybe I'm just using a keyboard wrong. The resting position for me is pinky straight on the control key. I have no resting position where my pinky is on the control key that also allows me to hit the W. Like, so if the pinky is on the control key and my hands are extended outward, this finger goes up to at most the S. So the truth is I have like small hands and like broad shoulders, so my hands are naturally curved this way when they are a bit more than most people, and also they don't extend as far out. So because of that, I have a lot of trouble typing. I think that might just be the answer. Anyway, I don't know why I got on that ramble session. I do apologize for that. Let's go back to convolutions, guys. I think like the problem is his pinky's too far up and he has to bend it down. The bending is the problem. The resting position for me is pinky straight on the control key. That's the way. It's just hard. Maybe I'm just doing it wrong. But also like, yeah, I'm so bad with using keyboard, right? I think I use 66% of the keys with the right hand and 33% with, wait, I think you're saying 66 with the left hand and 33 with the right. I guess everyone has their own way of typing. What do I do? What do I do? I don't have a consistent typing pattern at all, I don't think. I have to note that I have a laptop, so I have some space to rest my hand on. It has the advantage of having my thumb on the trackpad. I see. On my left hand, I barely use the index finger and pinky for control shift. Yeah, I still type at greater than 100 words per minute somehow. Wait. Okay, so now I'm like really thinking about typing theory. I'm just, okay, wait a minute. So, what do I do? Oh, yeah, I don't have a consistent typing pattern. I still look at the keyboard. Yeah, so I don't have to look at the keyboard, but I can't look at the computer. I've got weird things. Like really weird things about how I use my keyboard. Anyway, let's just ignore all of that. And let's start talking about convolutions, shall we? Pretty excited. Let's just knock this out. See where we're going to go. So I've been working on the revisions to the convolution chapter in the algorithm archive, and I've decided to split convolutions into 3 separate chapters. We have convolutions in 1D, convolutions in 2D, which is convolutions of images, and then the convolutional theorem. Now, the convolutional theorem will be essentially completely redone, but I wanted to make sure that it was in there so that if people had, like, it was in there so that I would remember to revise it later when I was doing the Fourier transform revisions. I use caps lock as my left control, like a normal person. See, that makes sense. Any updates on pull requests? There have been a few pull request updates. Let's go to github.com. In fact, let's just go ahead and do some, let's do some pull requests right now. We need to. The first pull request I kind of want to, I'm going to kind of check out here, is actually, okay. Let's just do some algorithm archive work right now. I mean, today's algorithm archive work anyway. So first thing I'm going to do is cd into projects, content, algorithm archive, content, ls here, cd into convolutions, ls, oh my gosh, cd convolutions 1d, lsvi1d.md. It's something that I just noticed on these chapters is that this image is wrong. So I'm going to fix that image. Oh no. For 1d, 2D, and 3D, and then I'm going to commit what I have, and then we're going to talk about some pull requests really quick. Yep, down here. It might just be an algorithm archive day. There's a lot of things that we need to update today. So that should fix all of the CC images at the bottom here. Convolutional theorem, yep. 2D, yep. 1D, perfect. Okay. Yeah, that should do. Okay, so now let's see, get status, get add dot, get status again, get add dot, get status. Okay, that should be right. Get add dot summary. All right. Let's just add some overall structure, convolution. Great. Okay, git push, upstream, origin? I believe origin. What am I doing? Branch, git push, origin, convolution, updates. Okay, great. So that's pushed. I'm going to go ahead and I think the first thing we're going to do is just fix the... Oh, I'm a bit worried to do the CI issue on stream. Let me go ahead and catch up on chat here. Don't people map caps lock to escape? That's the Vim way, I think. Also, it's a good idea, but I wouldn't be able to reach the left control easily. I've revised my pull request. I've updated my PGP key. Wanted to play a little bit with PGP keys today. That's totally fair. Anyway, I think it is right to spend a little bit of time just doing algorithm archive stuff. So, what I'm gonna do first is git branch, and let's do git checkout. 1 second. What am I doing? GitHub CI? Okay. Okay, it still builds. I was kind of worried about that one. All right, so let's do ls here. Right, of course. ls here. And let's just go into vi, I think .travis.yml is all we have to remove. So let's go ahead and do git remove. .travis.yml, and also git remove tools, and there should be deploy, and there should be update site travis.bash, git status, git commit-m, removing Travis CI files for the build. All right, git push. Origin, GitHub CI, and we're going to talk about what this PR is, and why it's probably interesting to talk about for just a second. Okay, so this is the PR I just put up recently. It should be removing builds. Okay, so if I do files changed, we should see a few files changed. Yes, a few files removed. Perfect. So what I'm going to do now is I'm going to ask if we can get Berquist to do a quick review here. I know I feel bad. And let's see, I also need to add some labels to this, which we're going to say duplicate, let's see, general, I guess. Yeah, so this is probably just a general PR. Okay, let me go ahead and catch up on chat here. Normal people map, that's also a good idea, but then I won't be able to reach left control key easily. Right, okay, so, right, so what does this do? So this is a way for us to migrate from Travis CI to GitHub CI. Now, you might be asking, why is that important? The reason it's important is for a few reasons. The first reason is that Travis gives us only a limited number of builds available every month nowadays. And essentially, every time someone submits a PR, it goes through the continuous integration. That's what CI stands for. Anyway, it goes through CI such that we know that the book will build and all of this kind of stuff. So basically, this CI thing is what allows us to test every PR and allows us to immediately deploy the PR to our website the moment that a PR is merged. So at this stage, I believe we have the ability to basically replace Travis, which again has limited, which is limited nowadays, with GitHub CI, and it should be fine. So here we say the CI will trigger on push and on pull requests, only pull requests on the branch master and only pushes on the branch master. The build here will basically run with the node version 12 point whatever. And essentially what we're saying here is we run npm install, we build the book, npm run build, we check the build in this way. And then we say if GitHub event pull request is merged, so as in if the pull request is merged into master, then we should be able to deploy the site in this way. And this is our script to deploy the site. Now, I know what you guys are thinking. This seems like a rather trivial thing to do. It took me like 6 hours to get this done. It took me forever. Like I spent like all day Christmas Eve just working on this PR. And it was fine, but also like it was stuff that I couldn't show you guys because it was It had like my special GitHub key and stuff associated with it and all this stuff. So it was rough. But anyway, I think it's done now. So I'm going to let Berquist take a look at it and see if he thinks it will work. And I'm also going to put a quick note on the conversation here saying that this has been tested on a separate branch. A separate branch and does deploy. And does seem to deploy correctly. We'll see if that's actually true. All right. So let's take a look at some PRs, see what we have here, and then we go from there. So pull requests, so we have 63, almost 64 pull requests. And let's see if there's anything that I can actually do here. So adding Computus and Vim, this seems like something that we could probably do. Feature, what is this? Let's see. So I'll keep the PR in mind and write the as we write the text for the next section. This one should probably be closed, but that's okay. Files changed. I believe this one can just be immediately merged, as long as it works. So I'm just going to go ahead and build this, or yeah, I'm just going to run this locally just to make sure that this works, and then we're just going to review the changes and go with it. So let's do that right now. All right, so the question is, how do you run nim? View command line instructions, grab this guy. Can we add our own content to the algorithm archive? The answer is yes in principle, but no in practice, because I suck at reviewing chapters. I'm promising myself that I'm going to do a few things. So one, I'm going to spend more time on the algorithm archive this year. That's kind of a loose promise. That's definitely going to happen. But two, I've got kind of, internal goals to make it so basically every week I submit a new chapter to the algorithm archive and we do this kind of stuff. So there's a lot of work that I intend to do this year, and we're just going to see where it goes, you know? So yeah, I'm going to try to do more reviews this year and stuff like that. Ultimately, both my YouTube channel and the algorithm archive kind of died in the past 2 years because I just haven't been able to spend the time to keep them alive. And so I'm really intending to do what I can to just, you know, revitalize the community and just grow this year, and hopefully grow to a point that it's kind of self-sustaining, but we'll see. Okay, so I'm gonna just do git checkout master, and then we're just gonna run this guy real quick. Git checkout. I don't understand what just happened. Okay. Right, okay, so CD projects. Sorry, what am I doing? CD contents, Computus, there we go, ls here. CD code, and then nim. All right, so first question, how do we run nim code? Okay, I'm so sorry. Nim by example, I just want to compile the code. Installation, oh, I can probably just do sudo pacman-s nim and see what happens. Right. Okay. So this might be a bit more complicated than I thought, but that's okay. So nim Arch Linux. Okay, nim, sure. Okay, that's exactly what I was hoping for. So sudo pacman-s nim. And it gives us nimble, which is the nim package manager, git bash. Okay, yep, let's do it. So the package contents here are, I think if we just run nim and then the file, it'll work. I'm just gonna guess and we're gonna see where it goes. So over here, I'm just gonna run nim. This unused file, nim.cfg, unused config file, Gauss invalid command, Gauss easter.nim. That didn't work. Okay, that's fine. So let's go over here and let's see how this works. It's probably about time that I learn nim anyway. So nim, how to run nim tutorial 1. Perfect. Echo, great. Nim compile, run greetings.nim. Great. Nim compile, run Gauss Easter. Okay, give it a second. Now, is this consistent with the Julia package? Julia ... One second. Julia Gauss Easter.jl. and 828, 1821. Yep, perfect. I think it is nimc. That probably could also work, but I didn't do that. Sorry. Okay, so here I'm gonna say the code's clean. Yeah, I mean, fine. This one's easy enough for me. Yeah. So I'm just gonna say I'm happy with this one. So let's just do review changes, approve, and say it runs and provides the correct results. Also, this one is just math, so I don't think we need to worry too much. Too much about stylistic interpretations, I guess. Let me code. Sure, that'll do. Approve, submit review. All right, that's a PR done, I think. Confirm squash and merge. Perfect. Okay, so now the next one. Okay, so let's see. Is there anything else that I can just tackle? Min-max stack example. So I didn't even look at things after Hacktoberfest this year. I was just kind of, what is this? Files changed. Oh, right. This is JavaScript? Okay. I'm gonna ask some dumb things. Let's see. I know the current algorithms are just for educational purposes, so the current format of the implementations are fine. But I'd like to see maybe a different directory for algorithm implementations formatted as libraries and packages, and there we could have also some kind of tests that would look the same between all languages, so that we can know for sure the algorithms are all the same no matter the language. For example, there are a few places where random is used, and we should have a way to code these in such a way to test them. Right. This is a failure on my part. I should have made it so whenever we do... I see what you're saying, right? Like, you need to make sure that we all have to start with the same seed or something like that. And even if you do start with the same seed, you have to make sure that across languages, you know, the random implementation provides the same results. This is why I tried to avoid using random when I did the tests and stuff, but that just didn't end up working the way that we thought it would work. Ultimately, I do have a test for every algorithm in the archive to make sure it works, but it's a very basic test just to make sure that, you know, with this set of numbers, it produces the correct results. And I try to pick the right numbers such that, you know, I try to, you know, take into account edge cases and stuff like that. I don't always do a good job of that, but I've been trying to make it so we can overcome that issue. But the idea of like turning some of the implementations into libraries is especially important when we start thinking about like Fourier transforms, for example. I mean, in practice, everyone just uses the FFTW library. That's just what people do. But in some languages, maybe that's not available. And there's like certain reasons why we might want to use an implementation as a library for other implementations and stuff like that. The trouble with that is that we might run into similar issues to what people have run into with numerical recipes, where they're so hyper-focused on their own, I guess you could call it API, their own way of doing things, that they end up not really, how do I put this? They end up writing code that's very difficult to read without fully understanding the libraries, plural, that they have created up to that point. That's a fear of mine, getting to the point that only people who have read the algorithm archive can read the algorithm archive. I want to make it so every chapter people can read, kind of standalone. But even so, I don't think we'll go that far. So I think what you said is a good point, and we should probably consider it in the future. So min-max stack example, here I want to say, let's see, files changed, example code, I think push... I'm gonna ask you a dumb question here. I do intend... let's see, I do intend to... Oh, sorry, I just dropped my pen. Eventually, add code to this chapter. So that... so this PR is fine. A good idea in principle. However, I don't know enough JS to say whether this is a good fundamental implementation of a stack or queue in that language. In fact, what is the difference between a min-max stack and just a stack and a queue? Min-max stack. I think this is different, isn't it? Like, min stack. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. I'm going to say that this... Okay. So this seems to do... Yeah, we don't need min or max, I don't think. I'm going to go here and I'm going to say my understanding is that this goes a bit further. Let's just go down here. My understanding is that this code goes a bit further to allow for outputting the maximum or minimum element in the stack, which is useful, but not necessarily, what I was thinking of for this chapter. All right, comment. Okay, great. Pull requests. So I think, we've commented enough on pull requests. I think now we can take a look at the convolution chapter and we can go from there. So let's go ahead and do that. And let's talk about what visualizations we need to make, and just see where we can get today. So I'm going to cd project algorithm archive, git status, git checkout, git branch, sorry, git branch -d. And what am I doing? This one. Okay. Now I'm going to, 1 second, git branch again. Okay. And we are going, 1 second. I've got to git checkout convolution update. And then I can remove that. That should do. Okay. So this should build, and we should have over here the convolutions updating and all that kind of stuff. So this should work now. F5 maybe, or not. Control C, try building it one more time. And then we should be able to start, updating the convolution chapter and stuff. So yeah, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. And I will totally address it as soon as I see it in chat. We have way more than 11,500 words, but that's okay. Move over here, F5. Okay, it seems like we have convolutions working. Okay. So for the chapters, I was going to do convolutions in 1D, where I was going to do a very basic animation of convolutions, and then a convolution with a triangle function, which will approximate a Gaussian. And so basically what I need to do now is I need to create two different convolutional images for 1D. So one is just a convolution with like a square wave and a Gaussian, and the other one will be a convolution with a triangle wave, a very basic triangle wave. And I think that's all we need for that chapter right now. For convolutions of images, I don't think we'll do convolutions of images today. We might tackle it tomorrow. But the idea here is that it's essentially just a 2D convolution. That's the idea with this one. But I wanted to highlight two specific operators that people talk about all the time when we're dealing with convolutions in 2D, and that's the Gaussian kernel, which is used for image blurring, and then the Sobel operator, which is the first step to creating image derivatives and kind of like edge detection schemes and stuff like that. Finally, after that, I want to talk about the convolutional theorem. I'm not going to create any visuals for this one today, but I will have it available for just to have up, and then later we'll fix it. So there's just stuff to do. But anyway, cd into contents, convolutions, cd into convolutional theorem. I just noticed that there was a typo here. Sorry. Yeah. Perfect. Okay. Becoming a fractal. Let's see. All right, legend. Thanks. I always wanted to be an oak tree. Cool, Gashi Deshida. I'm happy to hear that. um, but yeah, as far as becoming a fractal is concerned, so this will build into just basic convolutions, which are necessary for the fractal flame method, which is the first step to our becoming a fractal. We already have the fractal flame method working, so now it's a matter of kind of putting everything that we need into the algorithm archive, and then building on top of that. So we have to get the fractal flame method in the algorithm archive, followed by a bit on genetic algorithms, and then putting these guys together. I'm intending to create a library that will allow you to basically input any image you want and output an image that is a close approximation to that image made with basically different fractal functions. So that's the hope. Okay, so the next thing I'm going to do, I think I'm going to leave this terminal up in the background that's going to be building the algorithm archive. Let's make this huge, move this down here. Move this over there. Okay, and now we're going to cd into projects, cd into projects, Simuleos, Alice here, cd convolutions, cd projects, Simuleos, convolutions, Alice here. Okay, so we already have a whole bunch of images. I do not remember what any of these images are, so we're gonna have to kind of mess around with it a bit. Also, another thing, I'm gonna open up another terminal, cd projects, Simuleos, convolutions, Alice here. lstar.mp4. Okay, I've got a lot of. Okay, let's just see what happens if I do mpv outstar. What does this do? Okay, that one's cool. That's fine. Right, perfect. This one is way slower than I thought it would be. Oh, because it's out. Oh, I see what's happening. Yeah, okay. Ls. I'm going to do outstar mp4. Okay, great. Okay, so here's the first convolution. Let me see what the next one looks like. Great. That one looks the same. Perfect. Okay, that's a noisy convolution. Don't exactly remember why I was doing the noisy convolution, but that's fine. Yep. All right. I don't remember what we were doing with this at all. So, yeah, was the FFT multiplication algorithm from a few streams ago? No, it was not posted on the algorithm archive yet. We're pretty far from getting that done on the algorithm archive. I decided to take a break from the next 2 weeks because honestly, I was just getting burnt out and I was not having any of it. So I was like, screw it, let's just take a break, come back to it when we're ready. Alice here. So let me just go ahead and do Mirage out. Maybe, 1 second, something like this. 1.png. Okay, what does this do? I do not remember what this was doing. I think I remember now. It was doing a convolution of 2 Gaussians and then outputting the convolution at the end. But the thing is, I think we had to scale the convolution because it wouldn't fit on the same bar. Okay, but I think that's the visual I want. Yunzera, thank you so much for following. Really appreciate it. I hope you're having a wonderful day. 1 second. My event screen on the side here isn't really working that well. But yeah, the FFT multiplication algorithm will definitely go in the algorithm archive. It's just gonna be a few, maybe it'll be like a month or 2. It takes time. I'm sorry about that. I kind of wanted to tackle algorithms that we already have done, but just haven't really finished. And that's gonna be the goal for the next few weeks, just to get stuff out. Again, I'm trying to get something out in the algorithm archive every week from now on, so that we get some sort of forward momentum there, and get people reinterested in the stuff. So FFmpeg, I don't remember this at all. I'm gonna try to turn the series of images that we have into a video so that I can play it in the upper left-hand corner. That's my goal. I don't remember how to do that, so I'm just going to do ffmpeg out 505d.png -o out 6.mp4. Right. Okay, I think I need I. here, and there is no O. That work? Nice. So if I do M up here, MPV out 6.mp4, there we go, perfect. Okay, so Control C, loop 0. And I'll just have this playing in the upper corner, so when people come in, we can just point to it and say, ah, we're working on this. Great, okay. Move this down here, up here. So now it's time to just kind of refresh myself on the code that we were writing a few months ago, because honestly, I've completely forgotten all of it. Oh no. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. So, okay. Right. So let me just take a look at the code that we have here. ls*.jl. viconv.jl. Okay, so, right. Okay. I was also working on the correlation at the same time. So, right, let's just talk about what we're seeing here, and then we'll talk about why it's interesting, all that kind of stuff. So, what you're seeing up here on the upper left-hand corner is a convolution, right? So the idea is we are taking some original signal, which is going to be the blue line, and we are moving a filter across it. Now, the filter here is also the same as the original signal, and this is just a way to show that you know, we're just moving two signals past each other. And the idea is the convolutional output will be equal to kind of the sum of this green area, right? Now, the thing is that green area is the area of the overlap of the two functions multiplied together. So for example, if I stop here, oh, wait, 1 second. If I stop here, well, let's just go back a little bit. Oh, maybe. Sure. If I stop here, right, you'll note that this Gaussian is not the shaded region between the two of them, right? So it's not like shaded all the way up here, or even in the corners here, it's a little bit off. You can see that more maybe at different locations. So what this actually is a shaded version of like one Gaussian times the other Gaussian, right? So if you multiply the two Gaussians together, you multiply the two Gaussians together when they're overlapping, you're going to get this. And this is what the convolution is. So the convolution here is just kind of the integral under that, right? So you sum all this area up, and that's what you do. Now, this is kind of, if you look at the Wikipedia page, it kind of makes you think that the convolution is just the overlap, but it's not just the overlap. It's the integral of the two equations multiplied together, which is a clearly different thing. But at the same time, it's sometimes confused and it's sometimes difficult to understand. So that was why I specifically like this animation here, because it shows that it's not just the overlap of the two equations that you're doing here, it's the integral of the two equations multiplied together. Again, the only reason people have that misconception that it is just the overlap of the two equations is because if we go to Wikipedia, I don't know why, that was dumb, and just go to convolutions, here, there's a visual down here or something. Here it is. Which shows that the area under ft times gt is this kind of yellow region, and clearly that yellow region is the same as this blue region here, right? So like it looks the same as the shape of the blue region, and again, that's only because we're sending a 1x1 square through. If you don't send a 1x1 square through, then the area under ft times gt is going to be different, and therefore you're going to get a different convolution. So I think this is one of the visualizations I want to show. Now, the big issue with this, and the thing I want to look at right now, is that the convolution here, this little pink curve, is, I don't know how to put it, but I think it's misleading, because I think the convolution size should be twice the size, like twice the length of the other signals. So I want to see how we're actually plotting the convolution out right now, because I've completely forgotten what we're doing here. So here we have the convolution plot. We take signal 1, signal 2, and some sort of normalization factor for the convolution. Seems fine. Let's see, what are we doing then? So we say the time domain image. Well, I'm already lost, and that's okay. So let's see, we have I is equal to 1 to n minus 1. We have the inner domain between the two signals, and we say index is j minus 1, r sum. So let's take a look at signal plot and see what we got here. Signal plot. Oh, signal plot. Here. Okay, so what is this doing? It is plotting convolution. Outname is convolution, so it's going to be the real component of the output, which is fine. And then we do the label is going to be the output name, which is going to be convolution. It looks to me like in this case the convolution signal is the same size, which is weird to me. So let's see, the index, the residual sum is going to be the signal, the output of I. What? How does this work? Oh, now I'm like super confused. Okay, let's take a look at how this convolution linear is done, because I think I'm doing something dumb here. So n is going to be the length of signal 1. We're going to create an output array that is going to be undefined n, and we're doing the residual sum is going to be equal to 0. Then we say for I is equal to 1 to n minus 1. We have an inner domain saying j is equal to 1 to length of signal 2. And then we say if j is less than signal 1. So that means, yeah, if j is less than signal 1, then, so signal 1.length, okay, so then we start counting. So, okay, the reason this particular, I got it now, right. So the reason this particular convolution is not 2 times the size of the other signals is simply because we have this if statement in here that's kind of saying we don't count if we're outside of the domain. And then there should be if I minus j is less than 1. Let's see. If I minus j is less than 1, the index is going to be equal to the length of signal 2 plus I minus j. Okay, so I need to figure out some of the reason why we're doing these indexing in here. But ultimately, I think this visualization is pretty close to what we want to show for the visualization. I think the only other thing I need to say here, Aleb Chess, thank you so much for following, really appreciate it, is that I think what I want to do is make it so the area here is not actually the area. Maybe it says the area of, I guess we're going to say signal times filter. And that should do it right here. Chat got really quiet. So like, I'm a bit worried that like, I don't know. I get kind of worried whenever chat's quiet, but that's okay. Also guys, I just want to let you guys know, I'm still suffering from like rather intense burnout after the MIT position. This is not anyone's fault. It just happens. I'm going to be doing a short, like I'm going to kind of stick to the 2-hour streams today and probably tomorrow as well. And I'm going to start to try to incorporate longer streams throughout this upcoming week. I need to take some time just to just kind of rest and just kind of work myself into the new position, right? Like, so I just need to kind of work that out of my system, and it's going to take a little bit of time, and I'm just hoping that you guys are going to be a little bit, forgiving about that. So again, we only have another maybe 50 minutes or so in today's stream. I'm just trying to kind of slowly build up that stream stamina and stuff like that. So again, that's kind of why I'm taking longer ramble sessions and stuff like that. I'm just kind of, chilling out and, moving at my own pace right now. So I do apologize if that's, a bit slower than people want, but look, I mean, I got to deal with it at some point. So, I don't know what a smork is. I mean, I know it's an orc, but like, yeah, I don't know. Anyway, right. So I think that this is going to be too big. So maybe we say area under. Right. So I called it signal and filter. If you are not having fun with it, what's the point? I mean, there's a big point, even if I'm not having fun with it. I mean, like, I'm making educational content, right? Like, the truth is, not all of it is fun, right? Like, when you're making educational content, a lot of times it kind of sucks a bit. I mean, like, you just have to do stuff. But at the same time, it's more fun than, like, for example, gaming or, like, maybe not writing. I do enjoy writing a lot. But it's more fun to me than, like, a bunch of other things I could be doing. So yeah, it's good. It's just that, it's very easy to get burnt out at this type of thing is what I'm trying to say. And yeah, that's basically it. So at the same time, I mean, you guys know that I'm working my best to get, the upcoming videos out and stuff like that. There are points to things beyond having fun. Right, exactly. I think that's my point. I don't mean to say that like this job isn't great. Like the job's great, but also like, it's not like the reason I'm doing this is to have fun. Like the reason I'm doing this is to, provide educational content for people that they enjoy, that is useful to a large number of people, this type of thing, More fun than gaming. Yeah, it's way more fun than gaming. Gaming's super boring. Like I'm not going to go on a rant about anything related to gaming. I'm just going to throw this out there and say that gaming is one of those things that genuinely isn't fun, but is incredibly addicting, at least for me. And so most of the time when I'm playing a game, I don't like enjoy the process. I just do it because I feel like I have to do it. Like I feel a need to do it. And that's very like, I don't know how to put it. It's a bad place to be in. Like, yeah, it's a grind. Like every time I play a game, it just feels like a grind. Now, don't get me wrong. Like if you're playing a game with a friend, and the friend's enjoying it, it can be a lot of fun. Like for example, playing Smash Bros with a bunch of friends is super fun, really enjoyable. Doing Mario Party, playing Guild Wars with your guildies. All this is relatively fun. I enjoy that. But really, like back when I used to play Guild Wars and Guild Wars 2, the things that I really enjoyed were not actually playing the game, but just hanging out and chatting in like Camadon or whatever, and just like having fun. Just like I basically used Guild Wars as a chat service, right? Because I didn't have very many friends. Well, I guess I had friends, but that's the thing. Like it's just something you do to hang out. It's not something that you care about, right? And I think a lot of people get really invested in games, and it's one of those things that I don't fully understand either. Like, why is gaming so popular? I'll never know. I mean, I guess it's because it's something that's easy to unify people around. But I don't know. Anyway, so I call it signal and filter. I feel like I should call it something else, depending on what I called it in the chapter. So what did I call it in the chapter? I called it, what did I call it in the chapter? I called it F and G. So G is the filter, right? So I think I'm going to change the names here just to be F and G, so that it matches the name of what we have there. So this is going to be signal, which is going to be F, and this is going to be filter, which is going to be G. In fact, let's just change this so it is signal F and filter. One second. G. And then down here, we're going to say area under F star G. FG, I guess, because we don't want to use star because star is for convolution. So area under FG is what it should say. Let's write that, and let's just run this really quick and see what happens. So signal plot, what were we doing? So we had two signals. So we had the convolution plot. It read in two signals, correlation linear, correlation plot, main. So main here does... We have X, output convolution, XX, normalization factor 20. Okay, so let's go here and let's just see what happens if we run Julia, include. This time it's just going to be conv.jl, and now we're just going to run, I think, just main and see what it outputs. And it should output the same image. And now I just need to kind of mess around with the normalization factor and stuff like that. Because I think I actually want to... Yeah, let's just go ahead and mess with this. So we're just going to run main here and see what it does, and we're going to mess around with it a bit. Imagine having friends, because some people think it's fun. Yeah, that's fair as well. I guess you don't understand it for the same reason I don't understand why people enjoy sports, watching sports or doing sports. So to be fair, I do understand sports. I understand sports. Well, I don't understand watching sports, but I understand playing sports a lot. Like, for example, swimming is genuinely fun for me. Like, I love swimming a lot. Not open water swimming, just swimming in a pool, back and forth. It's meditative. There we go. You just kind of, you can work your body as hard as you want. It's super fun. I really enjoy it. The last one has the advantage of being helpful. You can do both because it's fun, something you can do with others. Right. So I guess that's my point, right? Like, if I'm hanging out with friends, I don't like going out I don't like eating with people. I don't like going to the zoo. I don't like, visiting islands and mountaineering. This is stuff I don't care about. In the same way, I don't really care about gaming. But if I'm with friends and, or there's a social aspect to it, I will deal with the stuff I don't like to hang out with friends, right? And that's kind of the way I feel about it, like, don't get me wrong. I'm sure a lot of people really do enjoy, single player experiences, and that's fine. But for the most part, the reason I enjoy, if I enjoy gaming, the reason I enjoy it is because of the community aspect, the fact that I'm playing with people that I respect and have a mutual respect for me and stuff like that. So, I mean, honestly, like, the reason I get addicted to Guild Wars and Guild Wars 2 is simply because when I'm playing those games, you're kind of focusing on becoming a good player, so you can kind of prove to your friends that you're actually, like, worth their time in a way. Does that make sense? Like, because your worth in the game kind of is related to your ability to play the game, right? So you play the game enough that you're good enough that you can be on their party and stuff like that. So the reason I get addicted to it is because I feel the constant need to keep improving myself in the game. And the thing about Guild Wars and Guild Wars 2 as opposed to World of Warcraft is it's not all just grind. You actually have to improve your skill. And it takes a long time to do that. It's really hard. Especially when I can't even hit the left control key, apparently. So, it's just addicting for me. It's not something I enjoy doing. Anyway, here I am rambling about gaming. I said I wasn't going to do that, and here I am doing just that. So let's just go ahead and take a look at Mirage. This .png. Okay. It says area under FG, convolution. Right, okay. So now the next thing I need to do is deal with this normalization factor. I'm going to change the normalization factor to be 1, and I'm going to do the same thing. Oh, I forgot to include it. Include. Now we're going to do main. And now let's take a look at that image. Here. Oh, that was not what I meant to do. Mirage. Okay, that's what I thought. The convolution is just way bigger than anything else here. Because we're summing over a large area. So I need to make it so we have the appropriate normalization function here. Did you play Dota 1 or 2? I did not play Dota, but my friends did convince me to play League of Legends for a while. Whenever I play these games with like a huge roster, I literally just pick a character and I just hone in on that one character. Because even if I suck at every other character in the game, if I can play somewhat decently at least one character, maybe 2 characters, then I can still play with my friends because they're usually like leagues ahead of me in the game. Like, they're usually way better than I am. So I have to get good at just one character, and then as long as I'm good with this character, like, I don't usually get crap from people. So the one character I hyper focused on for League of Legends was called Lux. At the time, she was like relatively unpopular. But I think nowadays she's really popular. And so I also played around Oriana's release, and I got popular with her as my backup character. I think Oriana ended up being better than Lux. But those were the only 2 characters I could play, Lux and Oriana. Lux is hot. Is she? Maybe? I don't know. I guess all the other characters are like demonic, like weird, like Lux is a character. There are very few characters in that game that I guess people would consider dating because most of them are not humanoid, I guess. So in comparison, I imagine, sure. Okay, so what do I need to do here? I need to do some sort of normalization. So how do we know what the normalization factor is? That's a good question. Thank you for asking. The normalization factor should be the sum. Wait, what is the normalization factor? Give me a second. Are we normalizing to the maximum area? I suppose that's what we're doing. We're summing to the maximum convolutional area, I guess. No, that doesn't make any sense. What is the proper normalization for a convolution? Normalization for convolution. Oh, actually, you know what I just realized? Our Gaussians are not normalized. A normalized Gaussian should not go up to 1. Let's read this in with a normalized Gaussian. Okay, and let's try that visualization one more time. So we have this guy. So how do we normalize? Do we have a normalization function? I don't think we do, so I'm just gonna like create my own normalization function. Maybe it exists. What happens if I do normalize? Hue, not what I was looking for. Let's try this again. Using linear algebra. Let's do normalize. I do have normalize, so let's just see what happens if we do normalize of something. I'm just going to create an array and just normalize it. So A is going to be equal to 1, 2, 3, 4, and normalize A. It seems to work fine, I guess. Is that right? Whatever. I clearly care a lot. Okay, so we have X here. Now I'm just going to do normalize X. Right, go up to the top here, and then using linear algebra. Perfect. Okay, so in here, we're just going to include, and we're going to run the visualization one more time, running the main function. And let's see what we get. Okay, so now we're going to run Mirage. Okay, right. So, okay. It's still really big. Let's try dividing it by 20 again and seeing what we get. So the normalization here will be 20. Okay. Oh, you know what I should have done? What if I just normalize? Then there's no point in a normalization function, is there? Anyway, let's just normalize the output here. So we do signal plot, and we're just going to do normalize there. Okay, try it one more time. Forgot to include. Now let's just run main, give it a second, and see what this one looks like. So if we do mirage out.png, really? I feel like we didn't normalize the output. Am I maybe not understanding what normalization means? Am I wrong? I thought normalize meant that psi star psi is equal to 1. Let's see. Let me try normalizing one more time. So normalizing, I thought meant, what does it mean to normalize something? Okay, now, okay, I'm sorry, we're going way back. Normalization. Okay, normalization. Refers to the process that makes something more normal or regular. Okay, thanks for that one. That's helpful. Okay, normalization, normalized convolution, a tutorial. I feel like we don't need a full tutorial for, right, okay. So let's consider a signal x1, 0, 0, x4, x5, 0, x7, 0, where xi are the known samples of the signal and missing samples of the signal are filled with zeros. Let's consider a simple smoothing filter, sure. Okay, it's not really, okay, that's not really smoothing. Well, maybe it is, but you know, usually when you think of smoothing, you think of blurring, so I thought Gaussian, but anyway. From the convolutional, from the conventional convolution of the signal with the filter, one would obtain a smooth one where gaps of missing samples have been filled with information available. That is the following, sure. The idea of a normalized convolution is that of associating to each signal a certainty component expressing the level of confidence in the reliability of each measure of the signal. In the case of missing samples, the certainty associated, okay, make this a bit bigger. That might be a bit too big, but that's okay. In the case of missing samples, the certainty associated with them is equal to 0. Therefore, we can express the certainty associated with signal f of t as a map c of t, which is the same as dimension f of t as defined as the following. Right. Okay, so there... This wasn't what I was expecting either. Okay, let me just... I swear, why am I so dumb? I must be dumb. There's no other solution. I just must be an idiot. Normalization, I just want normalization of array. What does it mean to normalize an array? Let's see. Come on, just give me... I know what I'm looking for. I just can't find it. Okay, give me a second. Normalize an array of numbers to specific ranges. How to normalize in NumPy. What does normalize in Julia do? Normalize Julia. All right, let me just see. There has to be some sort So in addition to, okay, normalize the array A in place so that its p norm equals unity. Norm of p is equal to 1. Right, that's what I expected. See, also normalize. Okay, that's exactly what I expected. So A here is equal to that. Normalize of A is equal to that. So norm of normalize of A should be equal to that. Perfect. Okay. Ah, wait, what? Wait. What does the norm do? Okay. Am I... See, also normalize and norm. Okay, let's see what we got here. I'm apparently dumb. So normalize abstract array p real is 2. So normalize the array A so that p norm equals unity. Norm of A, p is equal to 1. See, normalize and norm. Okay. Norm. Okay, so for any iterable container A, including arrays of any dimension of numbers or elements of type for which norm is defined, compute p norm as if A were a vector of the corresponding length. When will I be able to sell my channel points on a cryptocurrency exchange? I don't think that will ever happen. In fact, I'm at least 20% sure it won't happen. That's relatively high for me, so I'm going to bet it won't happen. Okay, the p norm is defined as the L2 norm. Yep, that's exactly what you expect it to be. So my question is, why doesn't the norm of V return a number? Oh, what? The norm of V does return it. Is this because A is an array? What? What? I don't understand. Norm of V in their documentation returns 7.0. But A here is a 4-element array of N64-1. V is a 3-element array of N64-1. But norm of... Is it a... What? So that's what I thought, but... No, because if you want to apply norm as a map on the array, you do norm dot of A. That's what you do there. Which for some reason is returning all ones. Okay, let me just do exactly what they have in this documentation. V is equal to this. Perfect. Okay. Norm of V. Bam. What? Am I like I'm not losing my mind here, right? Like 56k in the pocket? I don't know how much I have. I don't even know. Can I accrue my own channel points? Lux, wait, I will be able to tell. Nor should return a number. That's what I thought, right? I'm not the only one that's going crazy here. Broken documentation. Maybe some import. Yeah, let's just try Control D here. Open up Julia one more time. And let's try that again. V is equal to this. Norm of V is going to be using linear algebra. Now norm of V. Norm? I shouldn't have a norm function. And if I did have an... Oh, I do have a norm function. Oh, I see what I'm doing. I'm dumb. Yeah, so this is me being dumb. There is a norm function in here. Right. And I even have an is norm in there. Right. Okay. Right. Okay. So this should be changed to normalize. But then if we already have a normalize, should be fine. So I should be able to... Yeah, I should be able to remove these guys. Is norm. Is norm. So let's see. Function expectation value. So I think this can be changed to be if... Okay, so let's just mess around with this a bit. Let's do normalize of V. And then let's do the norm of that. That should be 1. Yeah. Okay, that's close enough to 1. Okay, so let's go ahead and remove these functions from our file. In fact, let's just go ahead and cp conv conv.jl into core.jl for correlation, and then vi conv.jl. And let's just remove all the functions that we don't need here, because there are a few that we don't need. So we can remove this. I think we can remove expectation value and covariance, and I think we need to keep convolution linear. I'm sorry, I'm dumb, guys. Like, it's hard. It's really hard being this stupid. Like, you know, you wake up in the morning and you think you can just like get out of bed, but like, it's hard. It's really hard. You guys don't understand. Okay, so let's go ahead and write that again. And now let's just try including conv.jl. Should be fine. It should build. And now let's try to run main. What do we have here? Do you have the norm function somewhere in your program? It's normalized. Can you stop saying you're dumb 24/7? Sorry, I cannot do that. It's pretty late, maybe. It's like 5:30 p.m. Okay, so now let's try running main here, and let's just see what happens. So, okay, right. So we're getting images out. Let's see. So if you do, let's go down here, and there should be. Okay, let's just see what happens if we take a look at this image. So mirage1.png. Okay, it's still very big, which isn't what I was expecting. So let me, from the function main, I'm going to return x. Write that, go over here, and now we're going to include this and run x. It's equal to main there, and we should get back our exponential function. Unfortunately, I can't plot it, but this should be fine. Let's do max of x. Probably maximum of x. No method matching is less complex. Maybe maximum over real of x. Should do it. Okay, 1.0. How then? Okay. If the maximum of real of x is 1.0, that means it is appropriately normalized, which is what we expected. I'm just dumb. The reason, I think I'm using the other function. Yeah, okay. Normalize. I gotcha. I understand now. Yep. That's why. Okay, let's go here. Let's just normalize this. Okay. And now we're going to run. Yep. So now we're going to run main one more time and see what this outputs. So if we do Mirage 001, it's still big. Why is it still big? Oh, did I maybe just forget to include it? Probably. Try one more time. Float64 series data for plotting. Can I convert Float64 to series data for plotting? That's because I want normalize. Yep. So let's try it one more time. Include main. Okay, let's spell it correctly this time. I did not do that. Let's try it again. All right, try it again. Main here. And now let's take a look at it. This should be appropriately normalized this time. There we go. Okay, so now it's normalized correctly. Oh, that looks a bit ugly. Yeah, that was not what I was expecting at all. Okay, now kind of understand why I was doing what I was doing before. So the convolutional output seems to be right. Okay, because we're normalizing at every step now. I see. Okay, so that's why we wanted a general. Right. Okay, I get it now. Because otherwise our convolution seems to be changing in size every time because we're normalizing it every time. Okay, so we then need to figure out what the normalization factor should be such that... So I think what we want to do is we want to... Right, so I think what we want to do is... sum this guy and treat that as our normalization function. Normalization factor. So that's probably why I had a separate normalization factor in here. So we do normalize out. So let's actually just change this so it just says out again. And we read in a normalization factor that's going to be equal to the sum of x dot times x, I think is what we want. Okay, so now if we're going to go here, we're going to do include convolution and then run main again and see what we get. And this should be okay. Mirage 001. Ah, that's perfect. Yeah, that is absolutely perfect. I mean, except for the fact that like, yeah, except for the fact that, well, you know, like the box is over that thing there. Everything else is perfect though. That's pretty good. Okay, great. So in that case, then, I think I want to move the box over just a little bit, and let's see. I want to change this. So I mean, it says area under F times G. That is true, but it's also been divided by. Should I say area under FG times max, or over max? Or I can just mention in the text that it's been divided by the maximum. Okay, so that's exactly what I wanted. Good thing our old code worked okay, outside of the fact that we redefined normalize twice, which is totally okay. You know, that happens sometimes when you make mistakes. So, what am I doing next then? I'm going to finish up this visualization today. I think the goal is just to get this visualization done. And I think we're pretty close to that. So how do we move the legend in Julia? So move legend Julia. How to change legend's place in plots GR. Okay, so we have plot. We have top right, bottom left, bottom. Okay. But how do we is there support for specifying number of columns in the legends list? Bbox to anchor, legend Bbox to anchor 1.051, location 2, border axis pad 0. If used pyplot directly. Okay, but we don't want to use pyplot directly. How to move legend to outside of plotting area in plots.jl. Maybe? Let's see. Grouped bar, let's see. Plot title. See, that wouldn't be too bad if we did it that way. I think that's probably fine. So where do they put, so title, grid false, show axis. Wait, where do they put the label item, map string, layout? Huh? So L is equal to at layout. What does that mean? Using layouts, I can create a workaround making, oh, I see. They're using a different package. Legend is outer top left. So do we want to move that legend to be, let's just check. We can move the legend to be outer top right. Maybe that's what I want, but really I just want to move it over just a few like centimeters, right? Like I just want to move it so it's like there's empty space right there on the plot. I just have to move it over a little bit. So specifying coordinates of legend, maybe Julia. Welcome to Simuleos, the stream where we try to figure out plotting. By the way, just Eli ask Errol. I'm sorry, I totally butchered that name. Thank you so much for following. Really appreciate it. 1 second. What about access border padding? Yeah, I can look at that. Access border padding. Let's see what happens. Access attributes. Access border. Specifying exact location. Location Julia. Okay. Oop, sorry about that. So, legends in the figure, location of the legend, the pyplot. So these are all using pyplot. I don't think I'm using pyplot. Let me see. What am I using? I'm just using the plots the default. So I don't think I can use that. Right. So legends on the figure, alternate legend placement via keyword argument. Legend position. Let's see, legend plot random. Okay, savefig. Plotly JavaScript. No, I'm not looking for plotly. X label, length, range. We can't just specify where the label is. Maybe, okay, what I could do is I could just output the data and plot it via GNU plot. that would be something I could do. And maybe that is what I do. Andrew, 16, 16, 16, 16, 16. Thank you so much for following. Really appreciate it. Okay. Let's see. Layout plots. Let's see. What does this do? Oh, no. Yeah, they have the exact placement. Perfect. Okay, so if we do layout, more complex grid layouts can be created. Oh, no. They just created 4 different plots. Maybe. Do I have to create a subplot to do this? Okay, what I'm considering doing is plotting this out in new plot, just because I know how to do this in new plot. But also, that's kind of cheating in a way. And does it really matter in the end? Like, is it okay? Like, I hate the fact that... Try looking at it one more time. Yeah, I don't think that's quite okay. Sorry about that. Maybe it's fine. Maybe we just leave it. I could... Could I move it to somewhere else? What if I move it so it is... Where would be a good place to move it? No, everything's used. Dang. That's disappointing. But I mean, if the only thing wrong with it is a legend placement, fine. Maybe it's okay. We'll leave it for now and say maybe we'll work on it later. So let's go ahead and just and do, is the last FFmpeg history grep FFmpeg? No, it's not in the history. Okay, that's fine. Let's just go over here. Quit. Do I have it here? I do. FFmpeg. Bam. There we go. Perfect. So that should give us our new visualization. Let's see, what am I going to do? MPV. So here's a new visualization. I think that's better. Like, in a lot of ways, it's better. So I think that's fine. I'm going to go ahead and put this into the algorithm archive since we have it. And then I will, so I'm going to put it into the algorithm archive chapter now. So let's CD projects, algorithm archive, CD contents, convolutions, Alice here. I should have a make directory resources, CD into resources, and let me go ahead CP projects, simuleos, convolutions, and then what did I call it? Out 6.mp4, and we're gonna call it 1D Gaussian animation.mp4. Sure, that should do. CD backup directory, CD into 1D, and then CD into 1D, or sorry, VI into 1D. Sorry, 1D.md. Now we should have the animation here. Now I always forget like what I have to do to put the animation in. So let's just go here. Where else do I have an animation? LD Hacker, thank you so much for the subscription. Really appreciate it. Let me go ahead and put a Simulecow, 5 Simulecows in chat. So that's Simulecow, and then I just need 4 more. 1, 2, 3, 4, 5. Thank you so much for the 5-month subscription. Really appreciate it. I hope you're having a wonderful day. Thanks for 2020. Mask up. So anyway, I really appreciate it. Thank you. So let's see. What am I going to do next? I'm going to do, let's go into VI, projects, algorithm archive. Then we're going to do, what am I doing? It should be contents and something that has a video. Oh no. Projects, algorithm archive, contents, probably computus.md, and then we should have mp4 in here somewhere. mp4, we do not. Okay, GIF? I swore there was an animation in here, but I guess not. That's fine. Okay, where else do we have an animation? Probably Gaussian elimination. Sure, let's go. There we go. MP4. There we go. That's what I was looking for. This little guy in here. Sorry, I always forget like exactly what I need to use with this. So we're gonna do /resources, and then whatever I just called it, which I think was. See, this is I should have remembered. I should have remembered, but I don't remember what it is. So we're gonna do whatever I called it. LS projects, algorithm archive, contents, convolutions, resources, and I called it 1D Gaussian animation. 1D Gaussian animation .mp4. I'm gonna write that, and that should make it so when we build the algorithm archive, video with supported format MIME type not found. Okay, I know what the problem is here. As dumb as this might seem, let me cd back. CD projects. 1 second. Mr. Undercover XYZ, thank you so much for following. Thank you for the quality entertainment. Yeah, guys. Yeah, I should probably watch more streams on Twitch. But let's go ahead and do projects, Simuleos, convolutions, LS here. And now I need to mogrify these guys, because if I go into GIMP out 1, 2, 3, 4, 5.png, you'll see that the size of this image, select, I don't even know how to explain, like, how do I get the size? Is 600 by 400? Oh, I thought there was like a, Okay, well, let's open up the Gaussian illumination visualization and check to see if that video is actually working, because it should be. Down here, the video is working just fine, but the one in convolutions is not. So convolutions in 1D, that is not working. Okay, I thought I knew the reason, and I thought it was because some of the images were the wrong size. So how do I output the size of an image in the terminal? Output size of image in terminal, right? So there should be file my PNG. Can I just do that? File. Okay. Out 1, 2, 3, 4 1.png. Interesting. So let's just do mogrify images. Let's see, mogrify resize maybe. In directory. Okay, sure. Batch resize images. There should just be mogrify resize, quality 100 path, start.jpg, magic mogrify resize, magic mogrify. Oh, is it a magic command? I thought it was just mogrify. Anyway, so resize. Quality 10 path new sums. Interesting. So batch resize, auto resize image based on folder. Well, okay, let me just see what happens. If I just do the resize to 600 by 400 for all of these guys, it should probably work, right? Okay, I don't know what I just did. Sorry about that. Move that back over there. Perfect. Okay, so now if I just do mogrify, resize, and then we do 600 by 400. New version mogrify only. Oh, that's good to know. Studio So 12, thank you so much for following. Really appreciate it. So it should just be resize 600 by 400. And let's just do out just to make sure it works. That should work. Okay, so now let's just do out star.png. Well, maybe I just need to do out star.png. That's not going to work. Out 0 star.png is what I need. Sure. Give that a second. Now let's try the last ffmpeg command. Yep. Now I'm going to cd into projects, algorithm archive, contents, convolutions, cd into resources, and then I should have a cp command up here that copies over here. And now I just need to rebuild the chapter. So if I touch, let me open up this terminal. I missed it again. There we go. Okay, so I'm gonna open up this terminal and I'm gonna touch convolutions.md, and that should rebuild it. It looks like it did. So if I go here, there, okay, F5, still didn't work. So I'm gonna just try rebuilding the entire site and see if that does it. Otherwise, I have absolutely no idea why this video isn't playing, and that kind of sucks. So I guess that's something else to figure out, but that's okay, you know, it's fine. This should not build right now. So if I F5, it shouldn't work. 1 second. Yeah, but it should build now. So if I F5 now, oh, okay, so now it does play. No, it doesn't play, crap. So Why not then? Is it because... Dang, I thought it would play. Okay, so how do I get this to work? No video was supported in format mime type found. Let me delete a lot of these tabs that we don't need. I don't think we need any of these tabs, if I'm being honest. So we're gonna go in here and just say, and just Google the error. No video was supported format. FFmpeg. Let's just see what we got here. Pixel format. Add this. Okay, let's try adding that. See what happens. Okay, so we're gonna. I'm gonna open up a new terminal. Well, no, I'm gonna go to this terminal over here, and then I'm gonna do cd projects, simuleos, convolutions. L is here, and now there should be an ffmpeg command on this terminal, which is that one in here. Paste that over here, and then we need to add this to it. So let's go back over here, and we're gonna add it. I believe here should be fine. So write that. Yes. Okay, let's try that then. So we should be able to copy the file over. 1 second. That should work. Now if I do the last touch, have it rebuild and see what happens. Ah, okay, there it is. Perfect. All right, so there's our animation. After a lot of trial and error, we got there. So let's go into vi.convolutions .md. And what I want to do is... Oh, okay, it is playing on loop. Great, so let's go into MP4 in here. Okay, MP4, okay. Ah, right, I'm in the wrong file. VI 1d.md, and then we go to MP4, and let's make the width slightly bigger to maybe 90%. That build, it's a bit big, but I think that's fine. Yeah, I think that's fine for now. Again, there's one more thing I need to do before continuing here, and that is to open up the Julia REPL one more time, and I want to rebuild the visualization by increasing the DPI. So let's go ahead and quit here. Right, okay, so let's go to vi.conv.jl. And we have the signal plot here, and what I want to do is make it so, let's see, save fig, and I believe I just need to do DPI is equal to 300 or something. DPI equals 300. Sure. Okay, let's try see what happens if we do an include here, and then we run main. Give it a second. Didn't think it'd take this long. That's okay. We run main. In the case anyone is interested, I just made a private repo public for an FFmpeg wrapper that I partially completed in Node and Shell for Linux. Oh yeah, cool. Let's see what this is. Paste this over here. Oh yeah, okay. I mean, I could probably use this, but kind of fell off the project after a while, and I've been meaning to get back to it. Yeah, honestly, FFmpeg is like super powerful. Let's do DPI plot. All right, let's see what we got here. It is in the plot function. So let's see, print line shift signal plot, and we're just going to do DPI 300 there. Okay, let's see what happens if we do include again. I think it's because I need to do DPI this maybe. Okay, maybe I did it wrong. It is DPI equals 300. The heck? Maybe because there's no semicolon? Ah, there is no semicolon. That's why. Okay, so now we're going to run main. This should create bigger plots, and then we should be able to create a higher quality animation. And then we should have a better animation for the algorithm archive. And I think that's where we'll close for today. Again, I'm just doing 2-hour streams for today, probably tomorrow as well. Just trying to, keep myself from burning out, which was a big problem last year. But I am making active progress every day. And I think that's good to start 2021 off, So what are we going to do then? I believe the next thing I need to do is go over here, Control D, run the last FFmpeg command. Yes. 1800 by 1200 seems like a very large file. Maybe 300 DPI was a bit much. Let's actually let's open up conv.jl one more time, and let's change DPI to be like 200. Julia, include. Yeah, that seems a bit. This seems like a bit much. Are you streaming early tomorrow? I'm not going to be streaming at 6 o'clock tomorrow. I will be streaming earlier than 6 o'clock. I don't know if that means I'm streaming at noon or if I'm streaming at 2, but I mean, I'm going to start streaming. Yeah, I don't know. I don't know when I'm going to stream tomorrow. It's going to be at like 4 o'clock in the afternoon Eastern time or before. So I don't know exactly how early before. It just depends on how I'm feeling. Again, I'm super burnt out from MIT, but I'm slowly getting my mojo back, and I just want to make sure I don't just like, you know, stamp out that flame like the moment I'm starting again, you know? So let's see. Yeah, so tomorrow I will be streaming, I don't know. So I've been streaming for 2 hours today. I want to do a bit of a longer stream tomorrow, so the earliest I would start would be noon. I don't really know. Control D, run ffmpeg one more time. 1200 by 800 seems fine. Yes. Okay, so now we're going to go over here, run the last cp command, which should be this one. Touch the file, because who doesn't love touching files? Am I right? Up top, I don't know what that means, I'm sorry. Okay, so we're going to let this go. That looks pretty good to me. Okay, so for our first attempt at a visualization there, I think that's fine. I'm going to have to update the text to explain what this is doing. And in fact, I think I probably want a bunch of different visualizations. Like probably I want to do, like I want to combine a bunch of convolutions together for this one. I'll think about what exactly I want to do, but the workflow is there, which is good. And that's usually the hardest part, just getting the workflow down. And then it's just a matter of like adding a bunch of visualizations together and stuff like that. So should be okay. I think that's where we're going to leave it for today. Let's see, what do we have here? We have about 30 people watching, so we should raid somebody. You guys want to do science or tech? What do you guys feel? We could also do charity or chess. Up to you. That light mode. Sorry, I use light mode. Hey, TS Jost, how are you? Oh no, wait, what? You were already here. Like for a while, whenever people say, hey guys, you're going to blind us? Look, I mean, you don't have to be blind. So the trick to watching this stream, like the trick is to carry sunglasses with you, right? And anytime I switch to light mode, you just put the sunglasses on. It's that easy. You know, it's not hard. I don't know why everyone's complaining about light mode. Super simple. I just don't, you guys are complaining too much. Anyway, that was a joke, by the way. Complete joke. Okay. So just watch stream with audio only. Okay, so what do you guys feel? Science or tech? Or charity or chess? You guys have any opinions? Let's do chess. Why not? Let's do chess. I don't usually raid chess, but let's do it. So I'm gonna go and start the raid on Botez Live. And that is good for today. So yeah, I just started the raid. Sorry about that. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. Again, I'm going to try to do streams more regularly. I did an awful job of that in 2020. But now we got a lot going for us in 2021. Maybe you can raid this. I just started the raid for the other stream. I can cancel that raid. 1 second. I think I'm just gonna go ahead and keep going with the raid that I have now. I tried to watch the stream, but then I had a 30-second ad, so I'm gonna go for now. That is it for today. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I'll see you guys around next time. Should be tomorrow, where we do another stream. Not sure about how long, but yeah, hopefully I'll see you then. Bye guys.